Hi, my friends. This is my YouTube channel. Uh, to get more videos, subscribe and like and share with your friends. So our today class is about the contour integral, finding the contour integral of the given function. This from negative infinity up to infinity sine d square x over 1 plus x squared dx. So using residue theorem and other techniques of integration, let's evaluate these integrals. So let's start. We know that sine square x can be written to the form of 1 minus cos 2x over 2. So replace this sine equation into this one. So what we have, the integral from negative infinity up to infinity, 1 minus cos 2x over 2 into 1 plus x squared dx. So I can write this like 1 over 2 the integral negative infinity up to infinity 1 minus cos 2x over 1 plus x squared dx. Again, also let us divide this function into two parts. So let me write this 1 over 2 into, so this can be written 1 over 1 plus x squared dx minus the integral minus infinity up to infinity cos 2x over 1 plus x squared dx. So now let's say f of x is the first integral, which is integral of minus infinity up to infinity of 1 over 1 plus x squared dx. And let's say g of x dx can be, this can be, we have here dx here, is the same as minus infinity up to infinity of cos 2x over 1 plus x squared dx. So let us solve for each f and g. The zero of this function and the zero of this function, both are, they have the same denominator. So we have here f of z becomes, which is 1 over z squared plus 1. So this also can be z plus I times z minus I. So at, let's say this is a star, at z equals to minus I and z equals to I are a pole of order 1, a pole of order 1, but the only pole on the upper half plane is z equals to I. So our only upper half plane zero value of this function is at z equals to I. That means we have this. So we know that there is I here, there is minus I here, so the only upper half plane can be found here. So that's why we can take d equals to I. So by residue theorem, we can find the residue of f comma at I. This is the same as by using residue theorem. This can be 1 over, we can use the derivative of the denominator, which is 2 times z. This is 1 over 2I. Or you can also use this, okay? You can also use the residue of f comma I is given by the limit at z tends to I into z minus I times f of z. This also 1 over 2I. They are both sides equal. The residue of f is this one. So what happened here? What is the result of the integral of f of z dz from negative infinity up to infinity is 2 pi I times the residue of f comma I. This becomes 2 pi I times 1 over 2I. What we have, which is pi. This is for star 1. Again, let's solve for the second function g. That means for star 2, we know that g can be given by g of z is given by, here is the integral of negative infinity up to infinity of cos 2x over cos 2z over 1 plus z square dz. So if we have this cos function with respect to the integral, so we can apply this technique, okay? That means our g function can be replaced by e raised to 2I, okay? Because we have 2, the coefficient inside the coefficient of z we have 2, so we can write e raised to 2I over 1 plus d square. Finally, we can categorize the real part and the imaginary part for the function. So let's integrate and let's find the residue of this function. So we know that this g of x have roots on the upper half plane at only d equals to i's are on the upper half plane. So let's find the residue of g comma I. That means if you derive this one, there is no z here, so we cannot derive it. There is no z, so it can be e raised to 2I. Sorry, there is z here, so put z here. So using techniques of residue, that means limit of at z tends to I, z minus I times e raised to 2iz over z minus I times z plus I. This is the same as this one, cancelled by this. So what we have, the limit at z tends to I, e raised to 2iz over z plus 1 is left. So if you put I into the function z, so we have e raised to minus 2 over, this is not I, this is I, so what we have, 2I. These are the residue of this function g. So what we have, the integral of g of z dz become 2 pi I times residue of g comma residue of, sorry here, residue of g comma I. This become 2 pi I times e raised to minus 2 over 2I. So what we have, 2I cancelled by 2I here, so we have pi e raised to minus 2 is left. So let's take this result and substitute to the function here. We know that as earlier here we are said, the function, this function can be divided into these two parts. So again, let's solve the gamma part of the function. That means for star the integral over gamma of r 1 over x squared plus 1, not z squared, z squared plus 1 dz is can be the same as 1 over z squared the integral plus 1 dz. This is less than or equals to the integral of 1 over z squared plus 1 dz. This also less or equal to integral of 1 over, this can be, is true for z squared minus 1 and dz. We know that the integral from over gamma r is, this is r, so this is through 1 over r squared minus 1 times dz. On the half plane it is semicircle, so we have 1 over r squared minus 1 pi r. This tends to 0 as r tends to infinity. Again, for star 2, the integral e raised to 2iz over 1 plus x z squared dz is can be absolute value into absolute value. This become e raised to 2iz over 1 plus z squared dz. This less or equals to, by triangle monotonicity of the integral of this e raised to 2iz over, this is the same as z squared minus 1 dz. This less or equals to 1 over r squared minus 1. This is exponential function, always this is always less or equals to 1. So we have the integral absolute value of dz. This is true for 1 over r squared minus 1 times pi r. This tends to 0 as r tends to infinity. So both the gamma functions are tends to 0. So our target is what, to find the integral from negative infinity up to infinity of sine square x over 1 plus x squared dx. This is equals to limit of as r tends to infinity, the integral minus r up to r of f of x minus limit of r tends to infinity of the integral of gamma of r of g of x and f of x here. Okay, both are 0 already here, so we have only this one, or we can say this is f plus, or finally I can use the function here. This means cos of 2x over 1 plus x squared. Okay, the integral of this means over gamma. This function is true for limit as r tends to infinity or this is 0, because before here we can show that both are 0 0. So finally let's make this short. This is 0, so finally what we have, but what remains left, there is a coefficient 1 over 2 from the previous one. Okay, there is 1 over 2 here, so this put 1 over 2 the function, so this equals to 1 over 2 of, you know, the sum of the limit of the given function f and g here, f plus g, let's say g of x here. That means the limit as r tends to infinity from the previous one, what is the residue? This is which is pi, we have pi here, and for g we have pi e raised to this, so directly substitute this one, so pi plus pi e raised to minus 2. So what we have, take out pi is common, pi over 2 into 1 plus e raised to minus 2 is the integral of the function minus infinity up to infinity of sine square x over 1 plus x squared dx. These are all about the solution of the given function. Thank you for watching my channel.